Welcome friends to another lesson at Educator.com in Intermediate C++. Today we're going to look at input-output a little bit more detailed than when we looked at it in the introductory class. So in case you've been doing C++ or taking the introductory class or doing other programming languages, what C++ uses are streams of bytes for both input and output. This is from the Unix and C legacy. Input and output are just considered streams of bytes in almost any instance, any case you can think of. Which, well, we're just sending bytes out, we're getting bytes back, and how you put those bytes together is up to the application and the devices. So we'll review the class hierarchy in input-output. And we'll look at briefly at the buffer class hierarchy, but we don't really use the buffer class that much except to know that they're there. Now the iOS base is the base class for all input-output streams in C++, and it has class attributes. It's got some formatting methods, state information. Then we have the iOS subclass, which is derived from iOS base, and all the other input-output streams are derived from iOS. So it adds some members and some functions. It adds a few more things you can do with input-output. Now we've got our input classes, which is iStream, ifstream. Now, of course, iStream is an input stream. if is an input file stream. And then we have an input string stream. We can actually do input in and out to an actual string. So it's as if it was an external device, but it's not an external device. It's actually an internal string, which lets you do some of the formatting that it normally does for input and output to devices. You can do that formatting to a string. Of course, we've got output classes. OStream, where there's an I, there's an O. Output file stream, OFstream, and OString stream. There's also an IO stream, which inherits from both input and output. And we have some status bits that allow us to detect errors. Or if the system detects an error, it will set one of the status bits to say, hey, something happened. You can use those status bits for parsing, but there is some cautions that we will talk about. We'll talk about using the string stream for input-output to a string. And we'll talk about how and when to flush those buffers. Buffers are used in just about all input-output because it's more efficient that way. The application can just put a few bytes at a time, a few bytes at a time. The system will just buffer up those bytes until it has enough to have one blast of input-output, whichever it is. Let's say you were doing output. We say, well, we'll fill the buffer. When the buffer is full, the system will say, okay, here's my buffer, it's full. We'll send it all out to the data. And that'll generally be more efficient, especially like for a disk drive, it's spinning around, whatever. So if you said, I'm going to send a couple of bytes there. We just got to wait for the disk to come around. Okay, here's your 3 bytes. So here's 5 more bytes. Well, we got to wait for the disk to come around again. So if you keep it into a buffer, when you wait for the disk to come around, when you just put out the entire buffer all at once, and so it's more efficient with buffering. So all the input and output is automatically buffered, but there are occasions when you say, well, we need to flush out whatever. The buffer's not full yet. Send it out anyway. So we'll talk about how that's done. And we'll talk briefly about internationalization issues. If someone wants their program to do their output in some language other than American English, there's things that you need to do. Some more simple ones are like the European languages. Some of the more complex ones are some of the Asian languages, which actually take up more than 1 byte. You'll actually need to probably get a third-party library for some of those, but we'll talk briefly about some of those. So we have streams. C++ input-output uses byte streams. Any sort of data transfer is considered a stream of bytes. They just go out in order. So we'll send a stream of bytes to an output device, whether it's a printer, whether it's your terminal, whether it's a disk drive, a tape drive, whether it's your string, and you receive a stream of bytes from the input device. So the user is typing things at the terminal. You're getting that stream of bytes, 1 byte at a time. Now, the bit shift operator is overloaded. And they picked that because it looked cool. It's, hey, we're outputting. This is our output to a stream output device. So they overloaded that. It gives you a formatted output. It's called the insertion operator because it inserts bytes into the output stream. And it's typically used for formatted input. If you're doing unformatted input, you would use write function instead of this. And the other direction is input. So this is the write shift operator, which is overloaded for input. And it's called the extraction operator, which extracts data from the stream of data coming in. And again, that's used for formatted input. We've seen in the intro class some of the I/O manipulators for output. Well, some of those manipulators can also be used for input. It says, I'm going to format this data to be so many bytes long. I will expect to see, or so many digits long. I'm going to expect to get so many digits in my input. Or I want my input to be a hexadecimal number. So you would put your hex in your input stream so that the stream processor knows, oh, I'm supposed to parse this data as if it was a hexadecimal number or an octal number, etc.